Hello guys, welcome to the video lectures of Excellent College of Arts and Commerce. Today we are here to discuss the topic of arithmetic progression and geometric progression. Before we discuss about the arithmetic progression and geometric progression, we have to know what is the meaning of some terminologies. First, what is a sequence? In arithmetic progression and geometric progression, sequence is a very important terminology. What is a sequence? A list of numbers having specific relation between the consecutive terms is generally called a sequence. I repeat once again, a list of numbers having specific relation. There must be a specific relation between any two consecutive terms. What is the meaning of consecutive terms? If you take an example 1, 2, 3, 4, 5, 6, in this 1, 2, 1 and 2 are consecutive terms, 2 and 3 are consecutive terms, 3 and 4 are also consecutive terms. There must be a specific relation between these consecutive terms, then the list of numbers is called as a sequence. We can understand it by taking few examples. First, an example 1, 3, 5, 7. In this example, the next term is obtained by adding 2 to the preceding term. For example, 1, 3. 3 is obtained by adding 2 to 1. 1 plus 2 is equal to 3. 3 plus 2 is equal to 5. 5 plus 2 is equal to 7. There is a constant specific relation between all the terms, that is plus 2. And another example 2, 6, 18 and 54. In this, the next term is obtained by multiplying 3 to the preceding term. If you take an example 2 and 6, 6 is obtained by multiplying 2 and 3, and 18 is obtained by multiplying 6 with 3. 54 is obtained by multiplying 18 with 3. Therefore, every term is obtained by multiplying a fixed or a specific related number, that is 3. I think everyone is perfectly understood what is the sequence. Next, what is a series? Series is the sum of sequences. The series is finite or infinite according to the given sequence is infinite or finite. What is a series? In simple words, we can say that if we take a sequence, if we add all the terms of a sequence, then it is known as series. For example, in the previous example itself, we took 1, 3, 5, 7 and so on. In this, if we add 1 plus 3 plus 5 plus 7, then that sequence is called as a series. Let us take some examples for infinite and finite series. First example, sum of first 50 odd numbers. This can be written as 1 plus 3 plus 5 plus 7 plus 9 and so on up to plus. The 50th odd number will be 99. Therefore, the obtained series is 1 plus 3 plus 5 plus 7 plus 9 and so on up to plus 99. This series is a finite series because there is a finite number of elements. Let us understand what is an infinite series by taking another example. Sum of all prime numbers can be written as 2, 3, 5, 7, 11. These are the prime numbers. The sum of all the prime numbers can be written as 2 plus 3 plus 5 plus 7 plus 11 plus and so on up to infinite terms. Then this type of series is known as an infinite series. I hope everyone understood this also. Next, what is a progression? If the terms of a sequence follow certain pattern, then the sequence is called as a progression. If all the terms of a sequence, let us take an example of a sequence 2, 4, 6, 8, 10 and so on, there is a certain pattern in this. That is, it is a sequence of even numbers, or every term is obtained by adding 2 to the preceding term. There is a certain pattern in it. Therefore, this type of terms of a sequence follow certain pattern, then the sequence is called as a progression. There are two types of progression. First type is an arithmetic progression and second is a geometric progression. Now let us understand what is an arithmetic progression. What is an arithmetic progression? If various terms of a sequence are formed by adding a fixed number to the previous term, or the difference between two successive terms is a fixed number, then the sequence is called as an AP. In simple words, to understand this, terms of a sequence are formed by adding a fixed number to the previous term. Then the difference between that term and the previous term will be a fixed number, then the sequence is called as an AP. Let us take an example: 2, 4, 6, 8 and so on. This is a sequence. 2, 4, 6, 8 is a sequence in which 2 and 4 are related by plus 2, 4 and 6 are related by plus 2, 6 and 8 are related by plus 2. In this example, the sequence is related by adding a fixed number, that is plus 2. Then this sequence is called as an arithmetic progression. Let us take another example: 5, 10, 15, 20, 25. In this, each term is obtained by adding 5 to the preceding term except the first term. If you take the first term as 5, then 5 plus 5 is 10, 10 plus 5 is 15, 15 plus 5 is 20, 20 plus 5 is 25. Therefore, every term is added by plus 5, which is a fixed number. Then this sequence is called as an arithmetic progression. I repeat once again: if various terms of a sequence are formed by adding a fixed number to the previous term, or the difference between two successive terms is a fixed number. What are successive terms? If you take an example of 1, 2, 3, 4, 5, 6, 1 and 2 are successive terms, 2 and 3 are successive terms. Any two numbers which are one after the other is called as a successive term. I think everyone understood what is an arithmetic progression. Next, general form of an arithmetic progression. The general form of an arithmetic progression is a plus d, a plus 2d, a plus 3d and so on up to a plus n minus 1 into d. Here, as you see in this equation or the general form itself, we can say that the first term is denoted by a and it is a. Next, difference is adding d to the first term is the second term, that is a plus d is the second term. Next, adding a plus d plus d to the second term, we get third term. Next, adding d to the third term, we get fourth term. Like that, d is a common difference which is a fixed number or a constant by adding to the every terms of a sequence. What is a common difference? The definition for common difference is the fixed number by which is obtained by subtracting any term of AP from its previous term. Common difference is nothing but a fixed number which is obtained by subtracting any term of a sequence by its previous term. If we subtract a term by its previous term, then what is the fixed number which we get is called as a common difference. Next, nth term of an arithmetic progression. Nth term is nothing but the sequence ends up to what number of terms is called as an nth term. If you take a is the first term and d is the common difference in the sequence, then nth term is denoted as an is equal to a plus n minus 1 into d. This is the formula to find the nth term of an arithmetic progression. Next, we can view few examples on a nth term of an arithmetic progression. First problem, example 3, 7, 11, 15 and 19 and so on. They have asked us to find the fifth term of this sequence. Here, as we can see, the common difference is 4. I'll explain it. 3 and 7. Let us take 3 and 7. The difference between 3 and 7 is 4. 7 and 11 is 4. 11 and 15 is 4. 15 15 and 19 is 4. Therefore, the common difference is a fixed number which is 4 in this given example. Next, what is the first term? As we can see in the question itself, the first term is 3. Next, n is equal to 5. How n is equal to 5? In the question itself, they are asked to find the fifth term. Therefore, n is equal to 5. The formula to find the nth term, that is fifth term, is Tn is equal to a plus n minus 1 into d. Therefore, T5 or an or Tn are both are same. T5 is equal to 3. 3 is the first term. 3 plus 5 n minus 1, that is 5 minus 1 into d is 4. Therefore, T5 is equal to 3 plus 5 minus 1 into 4. 5 minus 1 is 4. 4 into 4 is 16. 16 plus 3, that is 19. Therefore, the fifth term of the given sequence is 19. Let us take another problem. Problem 2. Let a is equal to 2, d is equal to 2, n is equal to 2. Find the nth term. In the question itself, they have given the values of a, d and n. We have to find out the nth term. What is the formula to find out the nth term? N is equal to a plus n minus 1 into d is the formula. In the question itself, they are given a is equal to 2. 2 plus n is 12. 12 minus 1 into d is nothing but 2. 2 plus 12 minus 1 is 11. 11 into 2. 2 plus 11 into 2 is 22. Therefore, arithmetic progression's nth term is 24 for the given sequence. I have also written the sequence. As a is 2 and the difference is 2, a is 2. 2 plus 2 is 4. 4 plus 2 is 6. 6 plus 2 is 8. 8 plus 2 is 10. And so on up to 12th term. 12th term is 24. So I have highlighted 24. This, I think everybody understood how to calculate the nth term of an arithmetic progression. Next, what is the sum of n terms of an AP? How to find the sum of nth term? Therefore, the total sum of all general terms of an arithmetic progression is sum of n terms of an AP. In simple words, if you take the general terms as a plus d, a plus 2d, a plus 3d, the sum of n terms is nothing but a plus d plus a plus 2d plus a plus 3d and so on. This is called the sum of n terms of an AP, arithmetic progression. The formula to find the sum of n terms is n divided by 2 into first term plus last term. Now, as we know, the first term is always denoted by a and the last term, that is Tn or an, it is denoted by a plus n minus 1 into d. Therefore, the final formula to find the sum of n terms of an arithmetic progression is Sn is equal to n by 2 into 2a plus n minus 1 into d. This is the formula or given equation to find out the value of sum of n terms of an arithmetic progression. Let us see few problems. The sum of 30 terms of given AP. We must find the sum of 30 terms of given arithmetic progression, which they have given the sequence 12, 20, 28, 36 and so on up to 30th term. Therefore, as they given in the question itself, a is equal to 12 and d is nothing but second term minus first term, that is 20 minus 12 is 8. We got a and we got d. Next, n is nothing but the 30th term, that is n is equal to 30. Therefore, the formula to find the sum is Sn is equal to n by 2 into 2a plus n minus 1 into d. Substituting the values of a, d and n in the given formula, n by 2, that is 30 by 2 into 2a, that is 2 into a is 12 plus n minus 1 is 30 minus 1 into d is nothing but 8. 30 by 2 is 15. 15 into 2 into 12 is 24. 24 plus 30 minus 1 is 29 into 8. That is nothing but 15 into 24 plus 29 into 8 is 232. Therefore, 15 into 24 plus 232 is nothing but 246. Therefore 15 into 246 is nothing but 3690, that is 3690. Therefore the sum of 30 terms of a given arithmetic progression 12, 20, 28, 36 is nothing but 3690. Next, we have perfectly understood about all the details of arithmetic progression. What is an arithmetic progression? General form of an arithmetic progression, nth term of an arithmetic progression, and sum of n terms of an arithmetic progression. We have perfectly understood everything. Next, we can go to the geometric progression. What is a geometric progression? A geometric sequence is a sequence in which any element after its first is obtained by multiplying the preceding element by a constant, which is called the common ratio, which is denoted by R. In the simple words, it is nothing but, if we take a sequence, the second term is obtained by multiplying. In a geometric progression, we get multiplying. That is, second term is obtained by multiplying a fixed number to the first term. Let us understand it by taking an example. The sequence 1, 2, 4, 8, 16 and 32 is a geometric sequence. How they say that it is a geometric sequence? Here the common ratio, that is second term, is obtained by multiplying 2 to the first term. The third term is obtained by multiplying 2 to the second term. That is 2 into 2 is 4, 4 into 2 is 8, 8 into 2 is 16, 16 into 2 is 32. Therefore, the common ratio, which is denoted by R, is equal to 2, and the first term in the given sequence is 1. I think everyone understood what is geometric progression. I will explain once again. A geometric sequence is a sequence in which any element after the first element is obtained by multiplying the preceding element by a constant. There must be a constant number, that is, in the given example the constant is 2. By multiplying 2 to the elements, we get the sequence. Next, the general form of a geometric progression. Each term of a geometric progression is denoted as A1, A2, A3, A4 and so on up to An. Therefore, the general form of an geometric progression is AR, AR square, AR cube and so on up to AR to the power n minus 1. This is the general form of a geometric progression. I think we understood it. Next, what is the nth term of a geometric progression? If we take the first term, A1 is equal to A1 and A2 is equal to A1 into R, A3 is equal to A1 into R, multiply R to every next terms. Therefore, the given nth term of an GP is An is equal to A into R to the power n minus 1. This is the formula to find out the nth term of a geometric progression. An is equal to A into R to the power of n minus 1. This is the formula to find out the nth term of a geometric progression. Next, we can solve a problem. Find the ninth term of the following series: 5, 10, 20, 40. They have asked us to find the ninth term. Then n will be equal to 9, and in the question itself they have given that the first term A is equal to 5. Next, common ratio. How to find the common ratio? Second term divided by the first term, that is A2 by A1, which is nothing but 10 divided by 5 is equal to 2. We can take another example. 20 divided by 10, 20 by 10 is also 2. 40 divided by 20, 40 by 20 is also 2. Therefore, the common ratio is 2. The nth term of geometric progression An is equal to A into R to the power n minus 1. This is the formula to find it. Therefore, An is equal to 5 into 2 to the power, what is n? 9 minus 1. Therefore 5 into 2 to the power 9 minus 1 is 8. 2 to the power 8, it is nothing but 256. Therefore 5 into 256 is 1280. Therefore the ninth term of the following series is 1280. Next, the sum of first n terms of a geometric progression. We understood what is the nth term of a geometric progression. Now the sum of first n terms of a geometric progression. The total sum of all the general terms of a geometric progression is called the sum of n terms of a geometric progression. As we understood in the arithmetic progression, similarly the sum of all the general terms in a geometric progression is called sum of n terms of an arithmetic geometric progression. If we take the general terms as AR square, AR cube, therefore the sum of n terms is A plus AR square plus AR cube and so on. To calculate the sum, we have a formula, that is Sn. Sn is denoted as sum of n terms. Sn is equal to A into 1 minus R to the power n divided by 1 minus R. This is the formula to find out the sum of first n terms of a geometric progression. We can solve a problem on it. How many terms of the series 1 plus 3 plus 9 plus and so on sum to 121? Here in the question itself they are given as A is equal to 1 and the common ratio is 3 and 1. Here first term is multiplied by 3 and the second term is also multiplied by 3, then we get 9, and the third term is also multiplied by 3, then we get 27. Therefore the common ratio is 3. We must find what is n. The sum of n terms of a GP is A into R to the power n minus 1 divided by R minus 1. This is the given formula. By substituting the given values in the equation, we get that n is equal to 5. I have written the series also. 1 plus 3 plus 9 plus 27 plus 81. Sorry. How do we get this series? 1 into 3 is 3, 3 into 3 is 9, 9 into 3 is 27, 27 into 3 is 81. Therefore, by adding all these 5 terms, that is n is equal to 5 terms, we get the total value of 121, which is given in the question. Therefore, the value of n will be 5. Thank you.